January 2013, Core 4, Question 4. We've now got to do our implicit differentiation question. So we're going to try and differentiate this term by term. The x squared, that's no problem, just goes to 2x. And the y squared goes to 2y. You've got to put a dy by dx next to it. And of course we're taking away them. The 8, don't forget the 8, it differentiates to 0. We've been asked to find out what the gradient of this is at PQ. So let's put the P where the X is here, that's 2 P's, and the Q where the Y is here, so that's 2Q equals dy by dx. The answer's given here, so we have to do some rearranging just to show that we can do this. Add those things to both sides, gives us 2Q dy by dx. Divide both sides by 2Q, gives us 2P over 2Q, and cancel the 2's. So the gradient is P over Q. So now we've got the one we just got here, and we're going to have another point as well, and we're being asked about the tangents. Well, the tangent that we're looking for has got an x value of P, a y value of Q, and a gradient of P over Q. Let's do that tangent. Y minus the y number equals gradient x minus the x number. I know I say numbers, but there's no numbers in this at all, is there? It's all just letters. Let's do the other tangent. This is tangent 2. And this time we've got the x as p again. The y, this time here, as minus q. And the gradient now is p over q, or p over minus q this time. So we've got that one. Here we go again. Y, I'll come back. Y minus the y number, minus q is plus q, equals gradient x minus the x number. Now these two things are meeting, so we want to solve these simultaneous equations. They intersect. Solving these ones, nice thing to spot, if you actually notice that this thing here is actually exactly the same as this thing here, but this one's negative. So if we add both of these two equations together, they're going to cancel each other out. On the left, we're going to get y, add y, which is 2y, minus q plus q, which is nothing. And as I just said, these two things are actually cancelling out. So I get 2y equals nothing. That tells you y equals 0. So if y equals 0 where they meet, well, that is on the x-axis, isn't it? Somewhere on the axis. Therefore, on x-axis. And the last part, there's only 2 marks because there's actually a really quick way of doing this, which I'll show you in a second. But I'll show you what most people did really. Most people spotted that we were talking about x squared and we were talking about y squared, and they just worked those out. So x squared is going to be t plus 2 over t all squared. I'm going to write it out twice. And we're multiplying that out, so t times t is t squared. 2 over t times 2 over t is minus, sorry, that should be plus there, shouldn't it? Plus 4 over t squared. And then we've got the middle term. Well, these two times together, the t's cancel out, so we've just got 2. Here's another 2, so there's a 4 there. Let's work out what y squared is as well, same sort of thing. And we're getting t squared plus 4 over t squared. And this time it's a minus 4 because of the minus inside both of those brackets. We have to take away these two things. So when we're taking them away, t squared take away t squared cancels out. 4 over t squared minus 4 over t squared cancels out. And we've got 4 minus minus 4, which was 8, as required. I said I'd show you the quick way of doing it as well. The fast way of doing this is just noticing that it factorizes into x minus y and x plus y. Well, when you add those two things together, if you add this and this together, then these two fractions cancel out and you just get 2t. If you take them away, then these two t's cancel out and you get 4 over t. The t's cancel out to give us 8, as required. Mark scheme here, and examiner's report says people weren't particularly successful in it, only 10% gained full marks, and lots of different ideas on how to do it.